Okay, I went way over time with the last one, so let's try this again. So, right. So the first thing I did is I just wrote up the requirements and then started going. I prefer to use IO stream over standard IO because I just find it to be easier. Also, I did have a using namespace STD in here, but I found that Visual Studios complained at me when I did that, so I just started doing this. Although I recognize there's an easier way to do that, I could have just said using std string, etc. Anyway, I'm also using strings instead of C strings because I prefer them. I find them easier to work with. And then we've got F streams in here as well. So, okay, now let's get into the thing. So, first thing I did is I made the linked list or double linked list class. We have a node here which contains the data and as well as a link to the next and link to the previous. These are pointers, so they will not contain a node themselves, but they will contain a pointer to a node, which means they can be changed, which is very important. So then in here, I just set everything to public because it's easier. I'm aware that setting things to private or protected might make things more effective, but that's not for this assignment as far as I can tell. So the first thing I did is I had to write an append function just to get the thing working at all because I had a lot of frustration with that. Also wrote a constructor here just to have one. I did not write a destructor because I forgot how to do that. We'll get to that later. So the append would check first if the data was, if the head was empty. If it is, then just it goes at the head. If the tail is empty, then it should go at the tail. And then also make sure to set the head to point to the tail. And then if neither were empty, then make a new node and then set the new one to the tail. And then make sure everything points in the right place. This part, I feel, should be able to be condensed down to a simple insert at position algorithm or function, but I didn't do that this time. Maybe next time. Okay, so then after I could work out that that worked, I then went to write the insert, and this one was where it got fun. So first thing I do is check if the head is empty. If it is, just make a new one at the head. Then, if it's not empty, then we check if the head we check if the data value is equal to the head. If it is, then we do nothing because we don't insert equal values. Then, if it's not the same, then we check if it goes before the head. If it does, then we make a new node and set up all the positioning so that it points in the right direction. So that means the new node is going to have to point to the head. The new node's next is going to point to the head. The head's previous is going to point to the new node, and then we're going to set the head to equal the new node. Then if it's not any of that, then if the tail is null, we're going to make it equal to the tail. We're going to set a new node that will be what the tail is. And then we're going to make sure to set the head so that it points to the new tail. Because if you don't do that, then it doesn't do anything. If you don't do that, then it doesn't link in both directions, and you can't walk down the array. I found that after many troubleshooting bits, and it was very frustrating. Anyway, already running late, so let's do this. Then this one was written before this function, which is why I have this bit up here. This is just saying if the tail is not null, and if it goes after the tail, then you do this part. And the reason I had that in there is so that if the tail was null, then it would just shortcut out. Of course, I forgot when I was writing that if the tail is null, then you gotta make a new tail. So this is not really needed anymore because of that, but I left it in because I thought it was better. I just didn't want to deal with it. The nice thing about doing it this way, though, is that if the tail is null, or if the tail is null, then this if is going to cancel before it ever tries to read this, which means it will not throw an error by checking tail.data. Anyway, so yeah, same thing though. We if it goes after the tail, then we make a new node and then put tail.next equal to that, and then the n.previous equals the tail, and then we set the tail to n. And that puts it at the end of the list so that the nexts all keep lining up the way they need to. Then otherwise it goes somewhere in the middle, and this is the fun bit where we go node w equals head. As long as head isn't null, do the thing, and then set w equal to w.next. I use w because it's a stand-in for walker. It's just to walk down the list. At least that's how I see it in my head. Which makes w a workable variable for that. That's also unique enough, typically, that I don't need to worry about anything else. So then if we find the same value, then we don't need to do anything. It's already in the list, so then we'd return. If we find the place that it goes behind, then we do all the shenanigans that we've been doing already, and then just insert it right into the middle. Yeah. And w.previous equals n means we're just setting the setting where we found the spot that it goes behind, and we're setting that to the back one. And then w.previous.next equals n. So once these two things are changed, the new value is in the list in both directions. So that's all we need to do for that, and then it's added to the list successfully, somewhere in the middle. And then we'll get back to this one. Let's see, I'm at 7 minutes, so let's keep going. Right, so then remove is going to do basically the same thing. There's just a lot less of it. If the head is null, then there's nothing to remove. If the value equals the head, then we remove the head, and then we set the head to the next value. And then if the value is equal to the tail, then we can remove the tail, and then set the previous one to be the tail, to be the new tail rather. And then make sure to blank out the previous or next appropriately, so that the new nothing value is actually not in there. Then if it's somewhere in the middle, then once again we walk down the list, looking for where to remove it. This might be able, you could probably just use this as this, but I felt like there were some scenarios in which it was better not to do that, because if it's at the head, then head.previous.next is going to throw an error. So we can't actually do that. So yeah, so that's why this is done. That's why you need these two ahead of it. I feel like there's probably a way to do it in one loop, but it's also not really necessary because an if statement takes barely any time. Anyway, and then we've got getList, which just, if the head is empty, then return nothing. Otherwise, make a string and start the output here, and then just for every element of the array, add that element and a space, and then check if the next one is null. And if it is not, then you keep doing that. And once the new node is null, then you exit. And then you just drop one of these in there and then call it good. And then return that. And we're returning that instead of printing it because I like using cout, and that lets you just do this. And it's a lot of fun. Anyway, so then, yeah, we're at almost 10 minutes, which is still better than the 18 minutes that I took in the previous one. Also, I didn't see that you wanted a video in there, so, or a facial video, so yeah, that's why we're redoing this. So this was me running the software. I decommented this part for this particular run, so it shows what the line of text is when you're going through, which is also right here. This is the previous iteration had a lot of frustration with the insert of this one. So, yeah, would not recommend. Anyway, this is the input file that I used, but it should work with basically any input file. The one that I sent you might be... I'm just gonna re-upload this one because it's easier. All right, cool. That should be it. So thank you.